Good day, everyone. Welcome to our second lecture in the data preparation series, titled Data Cleaning for Addressing Missing Values, Outliers, and Inconsistent Data Entries . Today, we'll focus on techniques to handle three critical issues in data cleaning: missing values, outliers, and inconsistent data entries. By the end of this session, you'll know how to address these problems effectively using Python on Google Colab. Let's start with the objective for today. Our goal is to learn how to handle missing values, detect and manage outliers, and resolve inconsistent data entries. These tasks are essential to ensure that your dataset is clean and reliable before proceeding to analysis or modeling. Python, with its powerful libraries like Pandas, NumPy, and Matplotlib, will be our go-to tool for addressing these challenges. Now, what is data cleaning? Data cleaning is the process of ensuring high-quality data by addressing issues like missing values, outliers, and inconsistencies. Without clean data, any insights or models you build may be flawed or misleading. For example, imagine analyzing a dataset with missing customer ages or inconsistent gender categories. It would lead to unreliable conclusions. That's why this step is critical. Reliable data leads to accurate insights and better decision-making. Let's move on to missing values. Missing data occurs for several reasons: user errors, incomplete data collection, or system failures. To address this, Python offers several techniques. First, we can remove missing rows or columns. This method is quick and useful when missing values are minimal or in non-critical columns. Second, for more meaningful data retention, we can replace missing values using imputation. For example, you can replace missing numeric values with the mean or median of the column. If the missing values follow a pattern, you can also use forward or backward fill methods to propagate adjacent values. In advanced scenarios, machine learning models can predict missing values. The choice of technique depends on the context and the significance of the data. Next, let's discuss outliers. Outliers are extreme values that significantly deviate from the rest of the data. They can distort analysis and reduce the accuracy of predictive models. To detect outliers, we can use visual tools like box plots or statistical methods such as z-scores and the interquartile range, also known as IQR. Once identified, there are three common approaches to handle outliers. You can cap extreme values within a maximum or minimum threshold, transform them using logarithmic or square root transformations, or remove them entirely if they are errors or irrelevant to your analysis. The approach you choose will depend on whether the outliers hold meaningful information for your analysis. Finally, let's talk about inconsistent data entries. These often appear as formatting mismatches, such as inconsistent date formats, capitalization, or abbreviations. For example, males might appear as M in some rows, causing inconsistencies in your dataset. To resolve these, Python provides simple yet powerful tools. You can normalize text for consistency, standardize date formats, or map inconsistent categorical entries to a unified format. These techniques ensure your dataset is consistent and ready for further analysis. To summarize, today we covered three critical aspects of data cleaning. 1. For missing values, we learned about deletion and imputation techniques like mean or median replacement. 2. For outliers, we explored detection methods using box plots, z-scores, and IQR, and discussed handling them with capping, transformation, or removal. 3. For inconsistent entries, we saw how Python can standardize text, date formats, and categorical data. By applying these techniques, you can transform messy data into a clean, reliable dataset. I encourage you to practice these methods on a real-world dataset using Google Colab. Thank you for your attention.